Okie dokie. So, this is the tougher titration questions. Right. You and all the little monkeys. I'm not going to show you the in-depth ideas behind it. I'm going to show you how to solve it. I'm going to show you how I do it really fast and the kind of things I look for. I'm not interested in that, but I still underline it. And it annoys me. Jabral, why does it annoy me?
Because it's in centimetre cubed.
Good. So straight away, I'm going to divide it by 1,000 because we make that mistake. Everyone makes that mistake, but not us oldies. So that's my first thing. So as soon as I see it, I think, oh my God, no, that should be in dm cubed, and I divide it by 1,000. Second thing, a student titrated 25 cm cubed of sulfuric acid, H2SO4, with 0.15 moles per dm cubed. Dm cubed, I love units. Units are brilliant. Of sodium hydroxide solution. The average titer was 18.6 cm cubed. This is sodium hydroxide, right? I should have underlined that. I was looking where it said sodium hydroxide. So 18.6 cm cubed of sodium hydroxide, and its conc was 0.15 moles per dm cubed. Now, concentration equals, look at this, it tells you moles divided by dm cubed. Well, you cannot compare masses and only moles, so we must find out moles. So our next task is moles. Now I start thinking, I need to work out moles. We need to rearrange this, or use your triangle. Please don't use your triangle. I hate them, but that's my personal thing. I want moles by itself, so I'm going to times by dm cubed. If I times this side by dm cubed, I must times that side by dm cubed. So concentration multiplied by volume in dm cubed equals the number of moles. Now, that is not dm cubed, 0.0186. Change it to dm cubed. I'm going to take my concentration, my conc, 0.15. I'm going to times it by my volume in dm cubed. It is this one, not that one. That's always 25. So you multiply the concentration of what you've got or what you've used against its volume. This is the only one you can do, 0.186. That will give you the total number of moles. So 0.15, always use a calculator, times 0.0186 times 0.0186 gives us 0.00279. This is science. Yes, I can do some of this in my head, but our job is to not make mistakes and be efficient. This is the number of moles of sodium hydroxide. Now, in the trickier questions, well, students will now go along and say, oh, that's the same number of moles of sulfuric acid. No, it's not. It is a 2 to 1 ratio. So you have twice as many moles of sodium hydroxide as H2SO4. If we've got, now I've got to be very careful with this, I'm going to say that again. You have 2 times more sodium hydroxide than HCl, than H2SO4. Let me get my acids right, H2SO4. So if I know I've got 0.00279 moles of sodium hydroxide, I'm going to need half the number of moles of H2SO4. There's a 1 there. We don't write it. Like 1x. Nobody writes 1x. We just write x. So I'm going to half it. I'm going to use my calculator to divide by 2. 0.00, how many zeros? Yeah, one more. 1395. This is the total number of moles of sulfuric acid. All right? And being cheeky me, you all use this formula now. Moles over dm cubed to work out concentrations. Moles divided by dm cubed. What you young ones will do is think, oh, I know what I'm doing now. I'm going to divide this by my volume, which was 0.025. Yeah, all right. That's so much maths. Maths is okay for little people, like mathematicians. But scientists were cooler. I'm going to simply times that by 40. And if you don't know why, go find out. There you go.